some inequality. Actually, the title, if I go to Schoology really fast, the title says it's solving intersections. A lot of like points of intersection, a lot of systems of equations that's happening here. So anyhow, let's go through this. And by the way, I labeled each page with a page number, so this hopefully should be pretty simple for the next couple of weeks. Like, hey, I'm on page 3 or page 4. Do the homework on this pages. So hopefully it's pretty straightforward. So let's talk about this word problem 264. Okay, so the diagram on the right shows a jackrabbit jumping over a 3-foot high fence. To just clear the fence, the rat must start its jump at a point 4 feet from the fence. Sketch the situation, write an equation models of the path of the jackrabbit. Show or explain how you know your sketch and equation fit the situation. Okay, so right below, here's what I do. So this is called modeling. When you hear the word modeling, what it means is how do you put an equation or a graph on the situation, right? So what I would probably do to make your life easier, it's kind of up to you, actually. I'd probably do this. I'd probably put X like this and Y like this. So you can overlay an XY coordinate plane on the diagram itself. So if you think about it, what's a vertex, guys? Let's do a little color contrast. Kind of nice holiday colors there, right? Okay, so given the way I've drawn this, where's my vertex? Where? 0, 0, 3. Okay. And if you write an equation in vertex form, remember vertex form is this. So don't want to jump the gun too quickly. But what do H and K represent? X and Y coordinates of the vertex. Okay, guys, quiet, please. Thank you. So far I know this. Okay, hopefully that makes sense, right? Because by deliberately putting the coordinate plane like this, like, hey, let's put the height at the vertex, right? The highest part of the jump, put the vertex there, which should make sense. And put the coordinate plane in this manner. It's pretty obvious my vertex is at 0,3. The A value is not as obvious. We can't assume it's 1. Actually, we have to algebraically solve for A. How do you think I would algebraically solve for A in this case? What do you think I should do? What are some other points on the graph that I know for sure? Where is it? Where -4 and where else? Oh, actually, that is hard to read. Let's make it darker. Give me a sec. And +4, yes. So the x-intercepts. Thank you for mentioning Alexandra. Okay, let's go dark blue.
That's actually my favorite color.
Okay, we'll go patriotic colors. How about that? Hey, Veterans Day. There we go. Yeah, that's perfect. Yeah, go America. Okay. Hey, Elise.
No.
Oh, let me get your notes. There we go. We just got started, so you're good. There you go. Okay. Anyhow, so you guys can see that better, and this was hard to read. Yeah, let me redo that. It's all good. We'll redo it, and I need more space anyway. Okay. So vertex, guys, quiet please. Thank you. So I can get to the notes here. So 3, 0. Sorry, 0, 3. My bad. Vertex form is this. We know this. AX minus H squared plus K. Remember, this right here is H, K. So you have Y equals A, X minus 0 squared plus 3. Okay, all's good so far. Now, how do I solve for A? What would I do? Well, I need to plug in a point I know, like 4, 0. So if I do that, I should be okay. 0 equals A, 4 squared plus 3. Remember, X minus 0 is the same thing as X, so I could just get rid of that and call it X squared. Make it a little easier for myself. Times X squared. And you should get -3 equals 16A. And what does A equal? Some wacky fraction, right? And it should be negative, by the way, because it's pointing down. So my final answer, which I'll put in dark green right next to the graph, is Y equals -3/16 X squared plus 3. Now this skill, Aiden, can you come back down? Thanks. Appreciate it. For those who are juniors taking physics, you're probably doing some stuff like this right now, kind of. Projectile motion, maybe. Acceleration, gravity, right? There's some modeling you do in physics, depending on how the physics class is taught. But a lot of times you have to do some modeling. You have to like have an equation describe a situation. That's what we're doing here. The equation describes the situation. So, all right. So questions on the jackrabbit problem. We're good? All right, let's keep moving. All right, so here's another one. This is dealing with sports. So I don't know, Ms. Wong is still athletic. She kicked a soccer ball, travel horizontal 150 feet. Maybe she is, I don't know, and reach a height of 100. I don't know if that's good, actually. I think so. Yeah. Well, yeah, she does put together notes, which helps me. So anyway, but what you want to do is let's model it again. So let's assume she starts at the origin. Okay. So we start here. And then the ball's kicked, and it lands somewhere later on, right? So really just understand physically what's happening. That's how you visualize the problem, right? That's going to make your life so much easier if you just visualize it. So what do you think the what do you think upon the y-axis? What y coordinate would this be? What do you guys think?
What?
Hold on. What's the height of the thank you, Aiden. The height's 100. And how far does it land away from her? So up at 150, there you go. Totally physics. And symmetry too. Yeah, pretty much. So what do you think the x coordinate is going to be of the peak? Using symmetry. Good. Thank you, John. Perfect. Excellent. So your vertex is this, guys. So it's really not that hard. As long as you now, did you have to model it this way? No. I could have actually put the vertex on the y-axis if I wanted to. But just being realistic, I put the person at the origin and then so however you design it's up to you. Because if I ask several other questions in relation to this situation, like, hey, you know, like how long does it take for the ball to reach this height or whatever, or all these different other things I could ask, at least you have the equation you can use. So remember, vertex form, pretty easy, right? What's H and K again? X, which is going to be what for this problem? And perfect. Awesome. And then how do you solve for A again? Plug and point, you know, for example, you can do 0, 0 if you wanted to, or 0, 150. It's up to you. I'll do 0, 0, I guess, because that's easier. So totally up to you what you want to start with. Come on, here we go. And I totally have to get a calculator, so it's gonna be a little hard to do without a calculator. If anyone could do 75 squared in a would be impressed. Too late. I got yeah. A point that you know. And the only point I know are x-intercepts. Yeah. And so I'm just going to leave it like this. Just going to be kind of a large fraction. Not a large fraction, but just large numbers involved. So the equation's pretty easy. It's y equals negative 100. 5625. X minus 75 squared plus 100. When I squared 75. When I squared it. It is negative. Yeah, it is. Yeah. So again, pretty simple. Visualize the situation. How does the jump look with a soccer ball, a projectile, whatever you're dealing with? Figure out your vertex and the other points. X-intercepts are pretty easy to utilize, and just plug it all into vertex form. So, and I think what you guys are doing in physics, you guys do use like y equals -1/2 gt squared plus v0t plus h sub 0, something like that. Yeah. That's physics. Obviously, I'm not going to do that here, but it's similar. But yeah, this is the work you have to show for this problem. Yeah, it would. Sorry. Yes, it would still work, right? Okay, we're good. No, okay. We'll take. No worries, take your time. Okay. Let's move on to. Yeah, we're almost done here. Just one more problem that's kind of, or two more problems. One's review. And you guys have to start homework and start creating stuff.
Four.
1, 2, 3, 4.
Third.
Who's fifth? Honestly, I'll just try to get it all done. How about that? Okay, I'll just move fast. Well, yours is AST. I can't get yours yet. Yeah. But I should get the majority done.
Mr. A, who's third, me or John?
Well, John should be a gentleman, dude. So John should be a gentleman. Let her go. Yeah.
Horse.
All right. Anyway, at the skateboard park. Okay, guys, quiet. The hot new attraction that you dipped a cement structure embedded into the ground. Okay, so it's a skateboard park. That's what's going on. So, okay. So like the one in Menlo Park by Burgess, right? You guys have seen that?
Tell me what it looks like.
That's what it looks like, I guess. I don't know. Okay, so kids are really young. I don't think so. Okay,
You never know. Crazy technology.
Skater boy John. Right?
maybe.
Yeah, right?
All right. So here's a skateboard park, and I deliberately put an XY plane on the graph. Now, they say that it's 40 feet wide and it's 15 feet deep. So I'm gonna have to be mindful about how I label.
You have to draw it.
Oh yeah, that's the whole point of this. Just unit, yes, it's visualizing. Yes, we have to. This is word problem heavy. Just it's a word problem heavy unit. Thank you.
Why, yes.
Yeah, thank you.
History.
I love word problems. Yes, sir.
Problems like this.
I mean, there's some that are actually more algebraic, like solving system of equations or inequalities. There's some physics involved. Yeah, this is physics, kind of, some ways. Well, not quite, because it involved time. Anyhow, let's take a look at this here. Okay. So it's 40 feet wide, negative 20 to 20. Hope that makes sense. Good, right? 15 feet deep. So I deliberately put the origin at the low point. That's quiet. I deliberately put it at the origin. So this is gonna be 15 at this point here. Well, the person that actually makes their way back up to the top of the ground level, or whatever you want to call it, ground level. So this right here has to be 20 comma 15. So again, find an equation. So y equals a x minus h squared plus k. Okay, what's my h and k here? What did I make h and k for this problem?
15, 20.
Well, hold on, no. My vertex is right here.
Oh, 0.
0, 0. So
If ground level was 15, then wouldn't it be negative?
it depends. I mean, so it would just depend how you draw it. Actually,
Negative 15.
no. If you put
But
yes, it would be negative 15, correct? Right. If you put the ground at the x-axis, you're correct. So it just depends on how you want to set it up. So there's not really a right or wrong way. But if I add an extra question saying, okay, now tell me how far the person traveled horizontally when they're like 10 feet high, you would still get the same answer. It doesn't matter what equation you set up. It's gonna be 0, 0, right? My vertex is 0, 0 for this problem. That just makes the modeling much easier if you can't put it at 0, 0. So it'd be x.
0, 0.
Well, like the last one we just did, the soccer ball. Remember I did 75, 150? 75, 100. It just depends on what you the situation. There's not 100% like a right answer. Like there's a variety of answers that could work. Now, how do I solve for a? What would I do? You got to plug in a point that another point on the graph. So 15 equals a 20 squared, which I know is 400, by the way. 400a. And it's opening up, so it should be a positive a value. So pretty simple, right? So my equation is y equals 15 over 400. You can, I'm not going to. You can, it'd be 5 over, sorry, 3 over 80, I think, 3/80, but it's okay. You don't need to. Again, if I ask like, okay, when a person's 5 feet off the ground, how far do you fell horizontally? It doesn't matter how you set up the equation, you still get the same answer. So if I ask like other parts of this problem. All right. So pretty straightforward. We're okay with that. Yes, sir. Cool. Good pacing. All right. Okay, I'll come and check on her in a few minutes. Yeah, thanks. Okay. Last part, guys. Quiet down. We're making great time here. Actually, cool. We got another half hour. Okay. How do we graph each of these? Well, this one I just start with the vertex. This one you might have forgotten, negative b over 2a. Remember I gave you guys that formula in the previous test. Oh, sorry, I need to give you the notes. Hold on. And I'm recording it so you can just watch the recording. Okay, negative b over 2a. So what's your b value for the second equation, guys? Thank you. And a is 2. 4 over 4, of course, is 1. So you see it's a little more work compared to the first. First one's easy. I just extracted, 1, 4, because I know my vertex form now, right? We've done a lot of work with that. Yeah, sure, good. No, ask it. What? No, because you go one right when it's minus. It's always counterintuitive. Yeah, no, it's a good question to ask. Very good question, because some people confuse that. It's confirmed with what I did in the second equation. And then of course I got to plug in plugging 1 back into the original equation and solve for the y value, which I should get 4 if I do it correctly. Yeah, I do get 4. So that's what happens. Now the x and y intercepts are a little bit more time consuming. How can we find them? Set y equal to 0 for x intercept. For y intercept, set x equal to 0. So, and then what are they? Or how do we find other points? I'd make a table. When you make a table, I usually would choose values close to the vertex, like maybe 2 or 0. If I put in 0, I should get 6. Plug in 2, you should still get 6 because of symmetry, which I think I do. I do. So do we have to find x, y intercepts? No, not really. I mean, you can if you want. And I know in the delta math it said to, and that was kind of a pain to do, but I didn't ask on the test. So you're totally cool with just oh, Jazzle, good. Yes, I didn't see your hand raised. Good. Yeah, you have to use quad form, or you can factor it. It's possible. Sure, yeah. It would. You should if you did the code correctly. 0,6 is probably somewhere over here. Actually, let me label. I'm getting lazy. 1. Switch back to black. Here we go. 1, 2, 1, 2, 3, 4, 5, 6. 1, 4, and 0, 6, and of course 2, 6. Gotta stop throwing stuff. Thank you. Well, need steady hands. Hey, I said please stop throwing stuff. Thanks. So, and they happen to be the same equation. They're the same thing, because if you were to expand it, you would get the same thing. So anyway, or if you were to factor this or complete the square, whatever. That's pretty cool stuff. Okay. So homework's right here. It's 1, 2, 3, 4. Looks like 7 problems, and some of the extra problems you might try them. You can see there's some solving, word problem. You can see the fireboat there. Find the vertex, just like the example we just did. Solving for x, another word problem. Finding intercepts, graphing a parabola. changing it to vertex form. Yeah, and the extra for experts, I didn't, it's not put here. You could just look at CPM, what textbook. All right, anyway, so that's it. You guys get to work. Heck yeah, oh, totally want to grade.
I think I would